So here's another example of how we can calculate mineral components as weight percent proportions. And in this case, we're going to take the albite and anorthite system as an example. So anorthite has the composition CaAl2, Si2O8, and the molecular weight, when we write it in this way on the basis of 8 oxygens, is 277.41 grams per mole. And then for albite, AB, we would write this usually as NaAlSi3O8. And on the basis of 8 oxygens, the way we've written it here, it would have a molecular weight of 263.02 grams per mole. So there we have anorthite and albite. And here's this very nice diagram from Dexter Perkins' online mineralogy textbook, where we can use the weight percent of albite to figure out the temperature at which a solid solution mixture of these two fellows would melt if we know their proportions. So let's make up a set of arbitrary proportions. Let's say we have a mixture that is about 1/3 albite plus 2/3 anorthite. And we're going to round these off just to make the calculations a little bit easier. We'll call this 0.33, and then this will be 0.67, and those two things will add up to 100. So very close to 1/3, very close to 2/3. Well, if we have a solid solution mixture that's not pure albite or pure anorthite, it's not going to melt at at these pure end member values, but something in between. And the higher the calcium content, then the higher the melting temperature. All right, we could see that. But we have these weight percent values, but when we write it like this, we're almost always talking about molecular proportions. So how are we going to change these molecular proportions to weight percent values? Well, what we'll do is we'll take these weights. So for anorthite, we will take 277.41 and multiply it by the amount that we've decided beforehand. We have something with 2/3 or about 67% anorthite. And so if we multiply those two fellows together, then we will get 185.86 grams per mole of this stuff here. And then for albite, if we had pure albite, it would have 263.02 grams per mole. But if we only have 1/3 of it, or 33%, we'll write it that way, then instead of 263 grams of that stuff, we will instead have 86.797 grams per mole. So if we have some mixture of these two, then we're going to have these weights. So let's sum those weights. So 185.86 and 86.797. If we sum those two things together, then we get 272.6613, and that would be in units of grams per mole. There's a little bit of error here because I've done some rounding up here and I'm carrying out decimals here, but if you do the calculation at home, you should get something very close to this. So what is this? Let's take a look at what this value means. If we had pure anorthite, then we would have 277 grams per mole. If we had pure albite, it would weigh less, only 263 grams. If we have a mixture that is 1/3 albite, 2/3 anorthite, then we get something in between. So we could check our calculation here. Is 272 in between these values? And it is. So what about the weight percent albite? The weight percent would be the weight of albite that we have in our mixture, 86, divided by that total, 272. So let's see, maybe we'll squeeze it in here, but put it in a slightly different color. So for the weight percent albite, we would have, so this will be the albite in weight percent, it would be 86 point, well, let's just round it off to 8 grams per mole divided by the total weight of our mixture, 272 point, and we'll just call it 7 grams per mole. We're going to multiply this by 100 to give us a percent, and that comes out to about 31.8 weight percent albite. And if we've done the calculation correctly, we could take 31.8, subtract that from 100, and that should give us the amount of anorthite, because there's only 2 components here. We couldn't do that trick if we had 3 or more components, but it's a game you can play to see if everything works out. So let's come back to trying to plot this and figure out where it should, at what temperature it should begin partially melting. So if we have something that is 31.8 weight percent albite, so here's albite decreasing from 100 to 0. So there's 20, 30, so 31.8, very close to 32 is going to be about there. We can run a vertical line as best as I can make it. That'll come up to there, and then a horizontal line across. Is that coming kind of close? Well, maybe not quite. You'd want to use a ruler at home. But you can have something above 1300 degrees centigrade for the beginning of melting of this kind of composition.